Hello there and welcome back to the Science Sleepy Minds. The sky above you isn't still. In fact, it's anything but. Overhead, galaxies swim slowly through the black, impossibly vast ocean of the universe. And tonight, you're going to watch as two of them, massive, swirling ancient systems, begin their long, slow journey into each other's arms. You're drifting near the edge of a spiral galaxy, tucked gently into a warm cradle of stardust. Your body is weightless, your breath steady, and the stars, they're moving, just barely, but unmistakably. One by one, galaxies turn their luminous faces toward each other, and some collide. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And let me know in the comments where you're watching from and what time it is. I love seeing how far and wide this sleepy little space has reached. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You spot them at first as two faint smudges in the infinite. One over there, rimmed in silvery blues, arms spiralling out like a pinwheel on its final spin. The other, darker, bulkier, older, lurks beyond a dust veil, just visible against the velvet black. Both are galaxies, and both, like tired giants in slow motion, are moving toward each other across the yawning emptiness of space. It's not a headlong rush, it's more like a slow, magnetic pull, like two foggy ships silently drawn together by invisible currents. Gravity doesn't shout, it whispers, and right now, it's whispering across hundreds of thousands of light years. These galaxies have been on this trajectory for millions of years, maybe billions. You, of course, just got here. Lucky you. You drift closer, and details emerge. The first galaxy, a gorgeous barred spiral, hums with newborn stars. Its arms are strewn with electric pink nebulae and glittering clusters. You might mistake it for a cosmic firework frozen in time. The second galaxy is messier, less symmetrical. There's a whiff of violence to it, like it's already been in one too many galactic scuffles. Some stars here don't follow orderly orbits. They swing wide like rebels in a forgotten parade. Between them, a void. Not empty, not really, just filled with things you can't see. Hydrogen gas, dark matter halos, rogue stars, and ancient light, and stretching across it all is tension. The kind of tension that says something huge is about to happen. But no one's in a hurry here. Everything unfolds in time-lapse. Even the light you're seeing left these galaxies millions of years ago. You're watching the past perform a slow, glowing pirouette. Historians, well, in this case astrophysicists, still argue whether certain galactic shapes are born or made. Some insist spirals are primordial, baked in from formation. Others argue they're the result of past collisions, shaped by gravitational chaos and gas compression. It's a scholarly tug-of-war with no clear winner. You for now, just float and watch. As the two galaxies inch closer, their outer halos begin to touch. These halos are invisible to your eyes, but real nonetheless, made of dark matter and sparse, faintly glowing stars. When they overlap, a kind of prelude begins. Their gravity starts pulling at each other's gas clouds. Tidal forces distort the edges. One spiral arm stretches out, then kinks like a flag caught in a sudden wind. The other responds in kind. You wouldn't notice the motion at first, not unless you came back in, say, 20 million years. Then, sure, things would look different. And here's a quirky little twist. The outermost stars, the ones orbiting lazily in the galactic suburbs, some of them get slingshotted away, cast off into the intergalactic dark. They'll become rogue stars, lonely travellers with no galaxy to call home. Think of them like the interstellar version of that guy who leaves a party without saying goodbye. You blink, and he's gone. Meanwhile, the two galaxies keep inching forward. This stage is called the first pass, the moment they first touch. Gravity going wild, arms warping, stars flung wide. But the cause? The dense, burning hearts. They miss each other, for now. You might expect a catastrophic explosion at this point, But that's not what happens. Instead, the galaxies glide past one another like sumo wrestlers who brush shoulders before circling back for the real bout. This is choreography on a scale that makes your brain whimper a little. From your vantage point, you see light being twisted. Long streams of stars, tidal tails, unfurl like glittering ribbons, stretching far into the void. Some of them may be 100,000 light years long. Imagine a silk scarf made of suns, caught in a gravitational breeze. Now imagine it's moving so slowly it takes 10 million years just to flutter. Oh, and that spiral arm that looked so pristine earlier, now it's mangled, warped into a trailing tendril. Beautiful, but battered. The galaxy will never look the same again. If you're wondering what happens to planets like Earth in all this, good question, but we'll get to that soon. Spoiler, most of them survive. Probably. Unless their star gets yanked out and flung into the void, or sucked into a black hole. But hey, what are the odds? Here's a historical tidbit to ground you. Back in the 1920s, Edwin Hubble, yes, the guy the telescope's named after, was the first to truly classify galaxies by shape. Spirals, ellipticals, irregulars. But he had no clue they could collide and reshape each other. That idea didn't gain traction until the 1970s, when computer simulations first showed galaxies smacking into each other like slow-motion jellyfish. So next time someone tells you all the big discoveries happened centuries ago, kindly remind them, galactic smash-ups, basically discovered after disco. As the first pass ends, the galaxies drift apart again, like dancers pushing away after an intense twirl. But not for long. Gravity is patient. It'll pull them back for another round. And you've got a front row seat. Or, more like a drifting lantern in space seat. Cozy. You're still adrift, somewhere between two slow brawling galaxies. Time here is thick, like honey left out on a cold morning. You barely notice motion at all, until you do. The galaxies have passed each other once already. That first sweeping encounter sent tidal tails lashing outward, stretching star streams into space like ribbons caught in a gravity storm. But now comes gravity's second act, and it's even more determined than the first. They're being pulled back together. You feel it in the motion of everything, the way each galaxy's core seems to lurch forward, as if realizing it left something behind. Spoiler, it did. A lot. Trails of stars, great blooms of gas, and probably a few unlucky planetary systems now dangling out in no man's land. It's all evidence that gravity never lets go. Not really. You drift closer to the spiral's bulging centers. They shine gold and red with older stars, packed so tightly they begin to lose individual identity. From afar, they glitter. From close up, they blind. This is the moment when gravity tightens its grip. The two galaxies are accelerating toward their second, and likely final collision. You hover just behind one galactic core, watching as the gravity well it generates pulls space-time inward, like a heavy stone thrown into a velvet trampoline. Not fast, but unavoidable. The gas clouds around both galaxies begin to compress. Not from any direct impact, stars rarely collide, but because their gaseous halos are now smashing into each other like two wet pillows. A shock front forms, invisible to the eye but very real. It crushes clouds of hydrogen and helium together with such force that starburst begins to spike. We'll talk more about that cosmic baby boom later, but for now, just know, the universe loves drama, and nothing stirs up drama quite like colliding gas. You're watching physics write poetry in real time. Now, about that invisible grip. You can think of it like a silent puppet master. Gravity pulls not just on matter, but also on motion. As the galaxy's momentum changes, you notice their graceful spirals begin to twist, distort, and fold inward. This is called dynamical friction, and it's less exciting than it sounds. Basically, it's like cosmic drag. When dense regions, like a galactic core, move through a sea of stars and gas, they stir up wake patterns that pull back on them. It's the same thing that happens when you walk through a pool and feel water resist you, except you're a black hole the size of 4 million suns, and the pool is space. Historians, well, astrophysicists again, still argue whether this friction effect is enough to fully explain why galaxy cores eventually merge, or if unseen dark matter plays a larger role. The models are good, but they're not perfect. That's kind of the thing with astrophysics. Lots of elegant theories, but space always sneaks in a curveball. Speaking of unexpected things, here's your quirky science tidbit for the evening. In the 1990s, scientists noticed something weird in the core of a galaxy known as NGC 6240. X-rays flared up in twin bursts. Turns out it didn't just have one supermassive black hole, it had two, dancing their awkward spiral toward each other after a merger. It was the first time we'd clearly seen the core-to-core clash beginning in a galaxy, and boy, it was messy. Think celebrity divorce meets gravitational doom. You drift forward again. The galactic centres are closer now. Only a few tens of thousands of light years separate them, which in space terms is the equivalent of holding hands. And all around, you start to sense the tension in the orbits of nearby stars. It's like a city grid being rearranged in real time. Stars that once orbited calmly in circles now spiral off into ellipses, or get slingshotted into longer, looser arcs. Some careen into the outer halo, never to return. Others get caught in these wild orbital limbos, unsure who they orbit now, Galaxy A or Galaxy B. It's not chaos exactly, it's transformation. But to a civilization unlucky enough to be near the galactic centre when this happens? Yikes. Earth, by the way, sits far out in the quiet suburbs of the Milky Way. If and when we collide with Andromeda, we probably won't even feel it. No star hits our sun, no black hole snatches us out of orbit. But if we lived in the galactic downtown, whole different story. You drift near a star caught in the gravitational crossfire. It wobbles in its orbit like a confused duck, veering sharply to avoid a denser cluster now pulled inward by the tidal effects of the second galaxy. Nearby, a planetary system does its best to hold together. Maybe it has life. Maybe it used to. Hard to say. But it's not where it used to be. As you float onward, you notice the galaxy's spiral arms beginning to wrap around each other like the tentacles of two sleepy sea creatures trying to get comfortable in the same bed. It's slow. So slow. But you know it's the beginning of the end for their individual identities. Their spirals will never untangle again. Their halos are now one. Somewhere behind you, a globular cluster, a tightly packed ball of ancient stars, is being yanked like a piece of taffy. Gravity's grip is so strong in this zone, it can stretch entire star groups like cosmic chewing gum. You're starting to see how galaxy collisions aren't about violence, they're about distortion. Everything gets pulled into new shapes. Fun fact, the Milky Way has already eaten smaller galaxies before. You're part of a cannibal. One of the clearest examples is the Sagittarius dwarf galaxy, which we've been quietly absorbing over the past few billion years. Poor thing never stood a chance, and we barely noticed. Now the two giants in front of you are almost overlapping completely. Their cores circle one another like rival monarchs, each refusing to bow. Not yet. That's coming. But for now you drift between them, and the void here is not empty. It's full of tension, motion, curved paths, heat, pressure. You hover, breath steady, caught between two dying spirals and one unstoppable force. You're still floating in the thick of it now, suspended like a dandelion seed between two ancient behemoths, locked in a gravitational embrace. You might think the chaos peaked already, that the first and second passes were the climax. But no, not yet. This next part is messier and more magnificent. Both galaxies are now thoroughly entangled, their shapes distorted, arms tangled like old earbuds. Some of their structure is barely recognizable. What once were elegant spirals are now thickening swirls and lopsided smears. You're witnessing a total identity crisis, in slow motion. In the vast middle zone where the galaxies have begun to overlap, something wild is happening. Gravity is stirring their shared gas clouds like a cosmic spoon in an interstellar soup. Thick rivers of hydrogen collide, compress and heat up. And that's the recipe for something glorious. New stars. Bright, hot, short-lived stars. They begin popping into existence all over the place like flashbulbs in the dark. Bursts of radiant blue in dense pockets. Star formation rates are suddenly off the charts. You're floating through a phenomenon known as a starburst, a phase where the collision compresses so much gas so rapidly that the galaxy gives birth to stars faster than at any other point in its life. Imagine floating through a galactic nursery, giant molecular clouds glowing from within, baby stars wrapped in dusty cocoons, and here's the thing, some of these stars are massive, 10, 20, maybe even 50 times the mass of the Sun. That makes them live fast, burn hot, and die young. You're looking at stellar rock stars with the lifespan of a fruit fly. Meanwhile, back in the calm pockets of the universe, other galaxies are just minding their business, plodding along at their usual sleepy star formation rate. But not this pair. No, this merging monster is firing off stars like a soda can shaken in zero gravity. Astronomers estimate that during a peak starburst phase, a colliding galaxy can form several hundred new stars per year. Compare that to the Milky Way's usual pace of about 1 or 2 stars a year, and you get an idea of how wild things are getting. It's like a galaxy-wide sugar rush. Of course, there's a cost to this productivity. Starbursts burn through their gas fast. Like a teenager discovering caffeine for the first time, the galaxy goes from, "Hey, I have so many ideas," to "I think I used up all my life energy in 45 seconds. Once the gas is spent, the star formation slows to a crawl. But for now, it's spectacular. You drift through one of these active regions and the light is unreal. Not yellowish like the sun, but hot blue and violet, like welding arcs stretched across the void. Clusters of massive O-type stars bathe everything around them in ultraviolet light. If you had skin, which you don't, because you're basically a sleepy, invisible observer in this narrative, it would be sizzling right now. And for the record, astronomers have found dozens of these real-world galactic starburst zones. One classic example, the Antennae Galaxies, about 45 million light-years away. Their sweeping tails and lit-up collision zone make them one of the most studied galactic train wrecks in the cosmos. They're basically the tabloid celebrities of the galactic collision world. Here's your historical fact. It wasn't until the late 20th century that we really started to connect galaxy collisions to starbursts. Before that, scientists assumed that galaxies just aged into quiet retirement. But infrared astronomy revealed otherwise. Turns out many of the brightest, dustiest galaxies out there are actively merging, and those starbursts, hidden under thick veils of gas and dust glowing like campfires behind smoke. Oh, and speaking of veils, those dusty clouds don't just obscure your view, they radiate. All that heat generated from collapsing gas doesn't go quietly. It glows in infrared, like embers in the dark. If you could see in the far infrared spectrum, you'd be blinking against the sheer luminosity of it all. You pause near one of these veiled birthplaces. A massive protostar is forming inside a dense cloud. Gravity is pulling the gas tighter and tighter. It spins, flattens, heats. Jets of plasma shoot out from both poles, carving tunnels in the surrounding dust. If it survives, this will be a blue-white star that lives a few million years and then collapses in a brilliant supernova. All in all, not bad for a cloud that used to just float around doing nothing. And yet, not all is peaceful here. All these new stars, they're kind of jerks. Massive stars produce intense stellar winds, basically streams of charged particles so strong they push gas away from future star-forming regions. Ironically, stars are terrible neighbours for other stars trying to be born. It's like trying to sleep in a dorm room next to a marching band. There's an ongoing scholarly debate about just how much star formation gets quenched by these winds, versus how much still sneaks through. Some simulations suggest winds and radiation from new stars help regulate further growth. Others suggest the opposite, that starbursts get prematurely smothered by their own success. Either way, you're watching the drama play out in real time. Zoom out a little and you'll notice something eerie. These regions look familiar, like galaxies themselves. Clusters within clusters, spirals within spirals. The scale shrinks, but the patterns persist. It's called self-similarity, cosmic fractals. The universe loves a motif. You're now gently drifting near the edge of one such stellar nursery. The light is soft here, filtered through dusty filaments. You can almost hear the static hiss of ionized gas and newborn radiation. There's no sound in space, of course, but your imagination fills it in. A soft hum, a lullaby of creation. Oh, and a fun, slightly weird fact. If you could somehow stand in one of these starburst zones and survive, the night sky would never be dark. Even between stars, everything would glow with diffuse light, like a permanent aurora borealis on steroids. Good luck ever sleeping again. You pull back now, gliding over the growing core of the newly blended galactic system. Below, the two former galaxies are nearly indistinguishable. Their arms blur, their cores spiral ever closer. But the real highlight isn't the clash of giants. It's the gentle birth of thousands, maybe millions of tiny new stars. And they'll live their short lives, blaze gloriously and die, all before the merger even finishes. You hang suspended above what used to be two galaxies, two spirals, two communities of billions of stars each, now folding together like molten glass. Below you, structure unravels. The crisp spirals have gone mushy. If you squint, you can still see where the arms once were, curving like question marks. But now they're smudged by motion, gravity, and sheer unwillingness to remain tidy. This is the moment their cores meet. It's not a head-on crash like you might expect. More like a dense ballet where everything moves, distorts, and shifts around a slow-motion embrace. The two bright, bloated centres don't slam into each other like billiard balls. They sink, inexorably, fatally into each other's gravity wells. The merger of galactic cores is a process as slow as it is final. Right now, they orbit each other, spiralling inward in ever-tightening loops. This stage is called core coalescence, and if you had 1 trillion years to spare, you'd get to watch the entire dramatic slow dance play out. You float just above the scene, two bloated golden bulbs of stars getting closer, pulled by gravity and nudged along by a strange phenomenon we touched on earlier, dynamical friction. Every movement a core makes through the galaxy's dense sea of stars creates a wake. That wake pulls back. It steals momentum, slows the cores down. It's like walking through molasses with bricks strapped to your feet. Eventually you just stop resisting and sink. And when they do finally meet, it's not fireworks, it's not a cosmic boom. It's more like two lava lamps slowly fusing together. Stars weave past each other in tangled streams. The gas compresses and heats. The shared core grows brighter, denser. Eventually it stabilizes, but it won't look anything like what came before. From elegant spirals to a massive shapeless bulge. Think of it as the post-holiday dinner phase of galactic evolution. Bloated, glowing, and very still. But let's not skip ahead too fast. Right now, you drift into the central region where the two galactic bulges overlap. The density of stars here is staggering. Picture this. In our region of the Milky Way, you might find 1 star per cubic parsec. Here, in this chaos, you'd see thousands. The light is golden, saturated, and unrelenting. Still, even in this stellar mosh pit, direct star-to-star collisions are vanishingly rare. Space, as always, is just so spacious. Stars are like grains of rice floating in Olympic-sized swimming pools. Even when the pools crash into each other, the rice mostly glides past, a little rattled, but unharmed. Here's the real showstopper. As the cores merge, their respective supermassive black holes, those titanic beasts lurking at the heart of each galaxy, start circling one another. And that's when things go from mildly disturbing to full-blown cosmic horror movie. You might imagine black holes as isolated predators, hiding in the dark, but here, they've met their match. Two giants, each millions or billions of times the mass of the Sun, now locked in a gravitational death spiral. A binary black hole. They orbit faster and faster, their dance tightens, and eventually, though it might take hundreds of millions of years, they'll merge in a final violent surge that releases gravitational waves powerful enough to rattle space-time itself, like ripples through the very fabric of existence. Back in 2015, scientists at LIGO detected these waves for the first time. Not from galaxies colliding, but from two stellar mass black holes merging much closer to home. Still, the principle's the same, and now astronomers scan the skies, listening for those low-frequency gravitational murmurs that would mean two supermassive black holes, somewhere, sometime, have just become one. But that moment's still far off. For now, you watch them spiral, slow, relentless, monstrous. Meanwhile, all around the central core, stars are being flung outward in strange elongated orbits. Some are pulled tight into the new gravitational well, others are tossed out toward the halo, their paths forever changed. There's a name for this strange transfer of energy, violent relaxation, which, let's be honest, sounds like a very intense yoga class. Violent relaxation is how the stars settle into their new roles in the merged galaxy. Instead of their old calm circular orbits, they now follow randomized paths, moving in all directions, at all angles. It's the beginning of a new order, not spiral, but elliptical. Smooth, puffed out, and more spherical than anything that came before. Here's a neat historical note. The idea of elliptical galaxies being formed through mergers didn't gain widespread acceptance until the 1980s. Before that, astronomers thought ellipticals were born that way, primordial and peaceful. But computer models and observational evidence turned the tide. Turns out they're actually the messy aftermath of galactic brawls. And a quirky tidbit for tonight. There's a galaxy out there called NGC 1316, which from a distance looks like a plain elliptical blob. But when you dig into its structure, especially with infrared, you find faint shell-like ripples, ghosts of spiral arms. These are the scars of past mergers, written into the stars themselves. You may have seen galaxies in textbooks, neat spirals, elegant bars, compact ellipticals, but real galaxies, they carry history, collisions, stretch marks, warped arms, hidden bruises. You're looking at one such galaxy being rewritten before your eyes. You drift further back now, giving yourself space to take in the full scene. The cores are nearly one. The rest of the system has begun to stretch into something new. Not two galaxies anymore, not quite one. A glowing, bulging mass in the final stages of transformation. There's a hush to it all now. The worst of the chaos is done. The worst, but not the most dramatic. That's still coming. Right now, you're just a witness to gravity in its most patient, most persistent form. It didn't need to explode anything to rewrite everything. You're hovering now in what used to be a galactic war zone, and surprisingly it's calm. The spirals are gone. The flailing arms, the tidal tails, the gas-shredding impact zones, they've all softened into something rounder, fuller, less flashy. If galaxies had faces, this one would be blinking slowly after a long, confused nap. This might feel like a quiet ending, but here's where the real perspective shift happens. Because for all the light and drama you just floated through, one fact has probably been haunting the back of your mind like a sleepy little ghost. Do stars actually hit each other when galaxies collide? And the answer, as underwhelming as it sounds, is almost never. Despite the galactic carnage, the odds of two stars physically colliding are so low, you might as well bet on a pencil landing upright if you drop it into a canyon during an earthquake. It turns out space is mostly, well, space. Consider this. The average distance between stars in the Milky Way is about 5 light-years. That's 47 trillion kilometers. Each star is like a speck of dust inside a football stadium. When two stadiums crash into each other, The dust doesn't go flying into explosions, it just keeps floating around, awkward but unharmed. So yes, stars mostly pass right by one another. They're too small and too far apart to care much about the cosmic scuffle going on around them, which is oddly comforting, in the same way that learning the Earth is unlikely to get squished in our own galactic merger might help you sleep better. Probably. Of course, just because stars don't hit each other doesn't mean everything is fine. Planetary systems, for one, are fragile little things. If a star's orbit gets tweaked, its planets might get flung out like change from a dropped wallet. Some could get tossed into deep interstellar space, doomed to drift frozen and alone forever. Some might crash into their own suns. Others could spiral in peacefully, only to get tugged out again by another passing star. So yes, even though stars don't collide, their planetary entourages, chaos. You drift past one such unlucky system. A star just got nudged by a passing cluster of mass. Its orbit is elongated now. One of its planets, maybe a gas giant, maybe a rocky one like Earth, is wobbling violently. Its seasons are ruined. Its tides are wrecked. Its moon has probably left town entirely. Not ideal conditions for life, but beautiful in that morbid, frozen space kind of way. Astronomers have actually identified so-called rogue planets. Planets not tethered to any star, just floating out there, alone. It's not hard to imagine how they got there. A galactic merger is basically the ultimate eviction event. One big gravitational mix-up and boom, your space roadkill. And here's a quirky little thought. Some of these rogue planets could have life. Subsurface oceans heated by radioactive decay. Thick atmospheres trapping the last breath of warmth. It's unlikely, sure. But then again, so is you, watching this cosmic show from the comfort of a simulated bedtime story. Back to the stars. You drift deeper into the post-merger core and the light has shifted. It's no longer brilliant blue from young, massive stars. It's more golden, like a candle slowly burning through the wax. The newly formed galaxy is older now, just a little. And those new stars, the big ones have already started dying off. Remember those short-lived O and B type stars from earlier? The massive luminous ones that burn 10 times hotter than our sun? Well, they don't stick around long. A few million years and they're gone. They go out in style though, supernovae. Giant, furious eruptions that blast matter into surrounding space and leave behind neutron stars or black holes. And while stars don't collide often, you know what does love to crash? Gas clouds, massive ones, hundreds of light years across. These clouds are messy, full of dust and extremely social. When they meet during a galaxy collision, they compress each other violently, sparking shockwaves that trigger even more star formation, or sometimes just collapse into black holes directly. Historians of astronomy, yes, they exist, still argue about whether all elliptical galaxies we see today are products of mergers, or if some formed independently in the early universe. Some galaxies seem too symmetrical, too pristine, to have been through such violence. Others bear all the scars, tidal tails, warped disks, shell structures like ripples in a pond. It's a galactic cold case file, and everyone wants to be Sherlock. You, of course, are more of a sleepy Watson, just here to observe. Here's a fun fact before you drift too far. In 2008, scientists observed a pair of colliding galaxies named V689, nicknamed the Angel Wing because, well, it looked like one. Gorgeous symmetrical wings flaring out from a messy core. It wasn't a simulation, it wasn't CGI, it was just two real galaxies 600 million light years away, caught in that perfectly poetic moment when destruction looks like art. You drift past the remnants of what used to be the spiral arms. Some stars have settled into wide looping orbits. Others now move in strange figure-8 patterns, victims of gravitational tug-of-wars that finally ended. Below you, the galaxy is slowly taking on a new shape. Not a pinwheel, not a flattened disk, but a soft oval, an elliptical. No more graceful spirals, no more arms, just a puffed-up swarm of stars moving in random directions like fireflies in a jar. This is the late phase of a merger. The chaos has passed, the damage is done. But the memory of what happened is written everywhere. In the orbits, the scars, the ejected stars now roaming the intergalactic dark. It's like stumbling across an ancient battlefield overgrown with wildflowers. You pass one more lonely star drifting slowly along the galaxy's edge. It wasn't supposed to be out here. Once it had a place in the core. Now it's part of the halo, exiled by gravitational kicks during the merger. It pulses faintly, a red giant nearing the end of its life, forgotten by the galaxy that birthed it. The silence out here is thick, peaceful, not final, but resolved. You close your eyes, metaphorically, and let yourself float. No one collided, but everything changed. You open your eyes, again metaphorically, and now you're gliding through something stranger, denser, and more volatile than anything you've seen so far. The galaxy behind you has begun to settle, yes, but there's a region you've yet to fully explore, the swirling soup of gas and dust that refused to play nice during the merger. Because while stars may glide past one another like polite party guests, gas does not. Nope. Gas is the drama queen of galaxy collisions. It crashes, it compresses, it flares, it throws a fit and then births a star cluster just to prove a point. And now you're right in the middle of it. You coast into a cloud the size of a small galaxy itself. Molecular hydrogen, carbon monoxide, ionized bits of dust all tumbling through space like whipped cream in a zero-gravity blender. And in here, pressure is rising, gravity is winning. This cloud is about to collapse into something new, possibly many new things. Welcome to the Chaos Zone. This is where the shockwaves from the merging galaxies did their finest work. When interstellar gas clouds from each galaxy collided, they didn't politely bounce off each other. They ploughed headfirst into one another at hundreds of kilometers per second, heating up and igniting enormous pressure fronts. Imagine crashing two ocean waves together, but instead of water, it's hydrogen. And instead of getting wet, you get stars. Right now, inside the dust, stars are being born by the hundreds, maybe even thousands. New clusters, binary systems, planetary systems still in diapers. Some of the baby stars will be flung out immediately by nearby explosions. Some will grow up quietly, orbiting each other for billions of years. Some will die in less time than it takes for you to finish your cereal. The environment here is intense. Harsh UV radiation, roaring stellar winds, an occasional blast from nearby supernova. It's like trying to grow up in a fireworks factory during an earthquake. Not ideal, but if you make it, you come out tough. There's a term astronomers use for these high-energy environments, starburst regions. You've floated through one already, but now you're inside the engine room. Inside, every few parsecs, you find dense clumps on the verge of collapse. Many of them will become stars. Others will sputter and disperse, victims of a nearby flare or a gust of solar wind that pushed too hard. Somewhere not far from you, a shockwave from a neighbouring star cluster just slammed through a dust cloud, compressing it into a pancake of gas. Within a few thousand years, just a blink in galactic time, that pancake will become a protostar, or maybe 6. It depends on how much mass falls in. It depends on how gravity feels that day. And speaking of gravity, here's your historical highlight. In the 18th century, French physicist Pierre-Simon Laplace proposed something shocking for his time, that nebulae, clouds of gas and dust, could collapse under their own gravity to form stars and planets. People thought he was a little out there, but Laplace was basically describing exactly what's happening in front of you right now, just without infrared telescopes or simulations running on supercomputers. Fast forward a few centuries, and now we not only know this is how stars are born, we've seen it happening in galaxies like M82, nicknamed the Cigar Galaxy, where intense starbursts are triggered by gravitational interactions. It's basically a galaxy-sized factory, puffing out stars like smoke from a chimney. And here's your quirky fact for the night. Some of the gas in this region, specifically in the post-collision mix, isn't actually native to either galaxy. It's primordial gas, left over from the early universe, floating between galaxies until it got caught in this merger like a stray sock in the laundry. So yeah, the universe recycles, sometimes billions of years later. You glide deeper into the dusty fog. It's thick here, lightless in the visible spectrum but glowing softly in the infrared. Filaments of dust coil around you, twisted by magnetic fields and gravitational eddies. You pass what looks like a dark tunnel, and it is technically a Bock globule, a dense patch of gas that blocks out light behind it. Inside, probably a future star cluster or three, or nothing. Hard to say until gravity gets serious. There's an ongoing debate among astronomers about how efficient these star-forming regions really are. In theory, these collapsing gas clouds should be forming stars non-stop, but in practice, something always seems to get in the way. Stellar winds, turbulence, radiation pressure. So the question becomes, what regulates the birth rate? Is it self-limiting, or are there galactic feedback loops at work? The models disagree. The stars, for now, are keeping their secrets. Just ahead, you spot something odd. A bright flash. A sudden, violent eruption from within a collapsing region. That, sleepy traveller, is a Herbig-Haro object, a newborn star firing off plasma jets as it accretes material. These narrow jets slice through surrounding gas at hundreds of kilometers per second, glowing where they slam into the dust. They're brief, fleeting, but they leave scars that stretch for light years. Imagine a baby hurling flashlights into space at high speed. It's that, but more dangerous. And all of this, the jets, the shocks, the magnetic turbulence, is happening because two galaxies decided to share space. The collision didn't just distort shapes and orbits, it lit the match on every gas cloud between them, turning quiet corners of the cosmos into raging nurseries of light. Now, drift up just a little, above the worst of the turbulence into a clearing of softer light. From here, you can see the larger picture again. Below you is a glowing cloudscape of future stars, a maze of gas trails looping and colliding and coiling inward. The stars themselves are still hidden inside, but their light will soon cut through. You're watching a galaxy rebuild itself from the inside out. No tidy spiral arms, no perfect symmetry, just mass, motion, and the will of gravity. You float higher now, past the last of the active star-forming regions. They dim behind you, flickering like candles through smoke. The galaxy is no longer at war, but inside its dusty core it's never been more alive. You drift outward now, rising gently from the turbulent belly of the merger. The crackling, gas-choked storm of starbirth fades behind you, its ultraviolet glow dimming like a nightlight left on in a smoky room. What you're entering now isn't calmer exactly, but it's clearer, and it's dazzling. Welcome to the starburst galaxy. It's not a permanent state, nothing in the universe ever is. But for now, this galaxy is in overdrive. Fuel is everywhere. The gas hasn't run dry yet. Gravity hasn't settled. The stellar nursery is still open for business, 24/7, no holidays, no breaks, and it's pumping out stars like there's a galactic deadline to meet. From your vantage point above the flattened chaos, you can see the glow from the starburst region at the centre. It pulses in blues and pinks, colours you'd normally associate with a neon sign, but here they mean something more primal: youth. Young stars shine hot and blue, their light slicing through the dusty veil like searchlights through fog. Around them, clouds of ionized hydrogen glow electric pink, lit from within by intense ultraviolet radiation. These glowing pockets are called HII regions, and if galaxies had birth certificates, these would be the ink stains. You float into one now. It's enormous, the size of a small galaxy in itself, filled with baby stars no older than a few million years. The gas here is hot, but the feeling is oddly serene, like standing inside a cathedral made of light. Everywhere you turn, stars blink into existence, not one by one, but in clusters, dozens, sometimes hundreds, forming from the same collapsing pocket of gas. Some are already large enough to bend light around them. Others haven't yet ignited. They're still in the protostar phase, quietly gathering mass until nuclear fusion kicks off and they light up like a match struck in the dark. Above you, a young star spins wildly, jets of material screaming from its poles. Below you, another is already burned out and exploded. Yes, already. That's the catch with these luminous giants. They're fast, bright, and doomed. It's a cosmic truth no one asked for. The more impressive the star, the shorter it lives. Meanwhile, the smaller stars, dimmer, redder, are settling in for the long haul. They'll live billions of years, quietly burning hydrogen, orbiting their cluster mates, occasionally getting nudged by a gravitational interloper or wandering planet. They're the cosmic equivalent of quiet neighbours who mow the lawn and don't throw parties. Respect. Let's pull back a moment. This galaxy isn't unique. These wild starburst phases have been seen before. One of the most famous is Messier 82, the Cigar Galaxy. A long, narrow system with a red glowing core that practically screams, "I'm stressed and making stars to cope." Back in the 1960s, M82 was one of the first galaxies studied in infrared light. Astronomers noticed it was way too bright for its size. That's when we started to piece together the story. It was experiencing a merger-triggered starburst, and the energy pouring out from all that stellar birth was heating dust and lighting up the galaxy from the inside out. A quick sidebar of weirdness. Starburst galaxies are some of the brightest objects in the universe in the infrared. That's because all the ultraviolet light from baby stars gets absorbed by surrounding dust, and that dust re-radiates the energy as infrared. So while these galaxies might look hazy or dark in visible light, they shine like lanterns in infrared surveys. Basically, they're the introverts of the galactic world. Quiet on the outside, loud in frequencies you weren't expecting. You drift through one of these glowing dust lanes now. It looks like smoke, but it's thick with particles, carbon, silicates, complex molecules. Maybe even the building blocks of life. The same kind of molecules found in comets and asteroids back home. This is the stuff future planets are made of, and you're floating right through it. In one corner, a particularly dense cluster of stars blazes with so much light, it's starting to hollow out the gas around it. That's feedback. Young stars pushing against the very cloud that made them. They do this with radiation pressure, stellar winds, and eventually supernova blasts. Feedback is a temperamental process. If it's too weak, the gas collapses uncontrollably. If it's too strong, it shuts down star formation altogether. Like trying to bake cookies while someone keeps turning the oven off and on. Astronomers still argue how important feedback really is in regulating starbursts. Some simulations show that galaxies self-regulate their star formation like a thermostat. Others suggest it's way more chaotic. Feedback either fails entirely or overcorrects. The jury's still out and likely will be until our models get better, or until a galaxy finally writes us back. You exit the star-forming region and rise toward the halo again, passing through the outer layers of the starburst. Things here are quieter, cooler. The light fades into softer reds and golds, but you can still feel the pulse from below. The newborn stars, the radiation pressure, the bubbles of hot gas expanding outward like shock waves. And now here's a quirky twist for your stargazing brain. Sometimes, starburst galaxies actually blow out their gas entirely. It's called a galactic wind, and it happens when all the feedback, supernovae, stellar winds, radiation, combines into a single, large-scale outflow that pushes gas out into intergalactic space. You can see it happening in some galaxies, like NGC 253, where giant funnels of gas stream out from the core like chimney smoke, and it's beautiful. It's destructive, and it's kind of a galactic self-own because once the gas is gone, star formation stops. The starburst ends, the galaxy dims, and what's left is quieter, puffier, older. But that's for later. For now, you're watching the peak. You float above it all, one sleepy observer gazing down at a galaxy mid-bloom. It won't last, nothing ever does. But right now, it's alight with new stars, bursting with the chaotic energy of change and glowing like a beacon across millions of light years. You turn slowly, taking in the panorama of light and dust, newborn brilliance and ancient shadows. And then you let yourself drift on, into the darker outskirts, where things get stranger. Now you drift beyond the glow. The starburst chaos fades behind you, and the light softens like someone just turned down the brightness on the universe. You're gliding into quieter territory now, calmer, yes, but far from empty. Ahead, nestled deep in the forming heart of this merged galaxy, is something darker than dark. Massive, patient, hungry, a supermassive black hole. Well, two of them actually, for now. You've heard about these beasts before, lurking at the centre of nearly every major galaxy, with masses that can range from a few million to several billion times the mass of our Sun. And when galaxies merge, their black holes don't just ignore each other and go about their lonely business. Eventually they meet, and what happens then is complicated. At this point in the merger, both black holes are still orbiting each other, embedded within their own stellar neighbourhoods. The gravitational well around them is so deep you feel it in your teeth, if you had teeth. You're close enough now that even light starts to behave oddly. It bends, smears and shimmers, warped by the dense curvature of space-time. You're witnessing the earlier stages of what's called a binary supermassive black hole system. It's not rare. We've found several of these pairs already. Galaxies caught mid-merge, their cores swirling around each other like sumo wrestlers circling before the slam. There's a famous one, NGC 6240, where twin X-ray sources betrayed the presence of two supermassive black holes slowly spiralling inward. The galactic equivalent of a double boss fight. Right now, you're hovering just above one of the black holes. It's not visible in the way you might expect. No swirling toilet bowl, no cartoonish vortex. What you see is the accretion disk, a thin, hot halo of gas and dust spiralling inward, glowing white-hot from friction as it prepares to vanish into the event horizon. If the galaxy is a furnace, this is its pilot light, always burning, always waiting. Occasionally, a rogue gas cloud tumbles too close and gets shredded into ribbons, lighting up as it falls in. These sudden flares are known as tidal disruption events, and they can outshine an entire galaxy for a few weeks. Astronomers love them. The black holes apparently do too. And here's the strange thing. Although black holes are often described as eating everything, they're not particularly efficient diners. Most of the stuff they attract doesn't actually fall in. It gets heated, torn apart, and sometimes flung back out in relativistic jets. Beams of charged particles that shoot out from the black hole's poles at near the speed of light. You glance to the side and see one now, a blue-white lance of light piercing thousands of light years into space. It doesn't come from the black hole itself. It's more like a side effect of the chaos around it. These jets are powered by twisted magnetic fields and rotating space-time. They can last for millions of years and carve tunnels through the surrounding galaxy, like cosmic laser beams with no off switch. There's still some debate about why some black holes produce these jets and others don't. It might depend on spin, or magnetic field strength, or just whether the black hole had a rough childhood. Theoretical models don't fully agree. Observations can only go so far. It's one of those we kind of know, but also not really zones in astrophysics. A cosy little grey area, like a mystery wrapped in plasma. Now, about those two black holes. They're still circling each other, slowly losing momentum through interactions with stars and gas. This takes time, hundreds of millions of years usually, but eventually they'll get close enough for gravitational radiation, ripples in space-time to do the rest. When that happens, it's game over. The two black holes spiral inward faster and faster, eventually colliding in an explosion so violent it sends gravitational waves pulsing through the universe. These waves stretch and squish space-time itself, like someone's thumping a rubber sheet the size of the cosmos. Back in 2015, scientists detected those ripples for the first time using LIGO, not from supermassive black holes like these, but from stellar mass ones. Still, the principle is the same, and when these two finally merge, it'll be the biggest fireworks display you'll never see. You hover between them now. It's oddly serene here. The space between two monsters. Light bends in bizarre loops. The stars around you orbit with visible confusion, tugged first this way, then that. Gravity doesn't pick favourites, it just keeps pulling. Fun fact, supermassive black hole mergers could in some cases kick the resulting black hole out of the galaxy entirely. It's called a gravitational recoil, and if the conditions are just right, the merged black hole could be launched at thousands of kilometers per second. That's fast enough to escape the entire galaxy. Imagine that. A rogue black hole, wandering the universe like an exile. Silent, invisible, unstoppable. So far we've only found a few suspected cases. One galaxy, called 3C186, appears to have a black hole speeding away from its centre, like it got ghosted by gravity itself. Back where you are, the black holes are still circling, still sinking, still waiting. You drift upward now, into the quieter regions of the core. Light dims, the star density drops, but the gravitational pull doesn't. It's everywhere, subtle, inevitable. This new merged galaxy doesn't have one centre. Not yet. It has two. But give it time. The universe always favours unity. Eventually. Above you, a stream of stars flows across space like spilled pearls from a shattered necklace. They were caught in the gravity well of the binary black holes and never escaped. Now they orbit chaotically, shining faintly in the cold void. Below, the accretion disks swirl, the jets pulse, the stars drift, and you float, quiet and weightless, above two sleeping titans on a collision course. You drift backward now, giving those twin black holes their space. Not that they need your courtesy. They'll find each other in time, gravity doesn't rush. Above you, the stars thin out a little, like a crowd dispersing after a concert. The chaos of the inner core fades. But you're not out of the woods yet. In fact, you're about to get weird with time. Because when you watch galaxies collide, you're really just watching the past. On a delay so massive it bends your brain into a Mobius strip. Every collision you see in the sky, every twisted galaxy snapped by the Hubble or James Webb, it happened millions, sometimes billions, of years ago. The light is only now arriving at our sleepy little corner of the universe. And here's the kicker. The collision you're watching now, it won't finish in your lifetime, not even in your species' lifetime. It's a process that takes hundreds of millions, sometimes billions, of years from first contact to final formation. And you, blessed with an attention span shorter than the average sneeze, are here trying to follow along in real time. Good luck. But for tonight, let's pretend you've got time to spare. Plenty of it. Enough to see a galaxy slowly change shape, to watch stars migrate and halos blend and structures settle. Right now, you're in the midst of that long, slow reshaping. The two galaxies you've been following are no longer distinguishable as individuals. They've passed the dramatic stage, the first punch, the flare-up, the core meeting. It's done. Now comes the part where the whole thing tries to remember how to be a galaxy again. You hover above the distorted midsection, where arms have melted and tidal tails are folding back in like noodles in a pot. The outer streams of stars that were flung out during the first pass have slowed, reached their apex, and are now being pulled gently inward. Like cosmic boomerangs. This process, known as phase mixing, is surprisingly elegant. Stars that were yanked into wildly different orbits gradually blend into smoother distributions over time. Their motions get less extreme, their energy spreads. It's like dumping different colours of sand into a jar and shaking until everything's beige. But don't mistake beige for boring. There's beauty in the slow shuffle of starlight. You glance to your right and spot a long stream of stars, tens of thousands, arcing gracefully through space like a ribbon tossed in slow motion. That's a tidal tail, still glowing faintly as it loops back toward the core. Some of those stars will never return. They've been kicked hard enough to escape. Others will settle into strange orbits, ghosting through the outer halo for eons. And speaking of halos, let's talk about the quiet co-conspirator of every merger, dark matter. You can't see it, can't touch it, but it's there, massive, invisible, and very clingy. Each galaxy brings its own dark matter halo to the collision, and while the stars and gas make all the visual noise, the dark matter is silently shaping the whole event. Right now, the two halos are overlapping, merging, becoming one larger halo. It's the scaffolding around which the new galaxy will be built. The stars will settle inside it, the black holes will drift within it. It's like the galaxy's skeleton, and we don't fully understand how it works. There's still plenty of debate among physicists about whether dark matter behaves like a fluid or a collection of particles, whether it clumps or streams, whether it interacts only through gravity or has other tricks up its cosmic sleeve. The models disagree. The observations are frustrating, but everyone agrees on one thing. Without dark matter, galaxy collisions wouldn't look anything like this. Now, back to your visible stars. You pass a small knot of them clustered together, too compact to be part of the larger structure, too old to be newly formed. This is likely a globular cluster, and it may have once belonged to one of the original galaxies. Or maybe it formed during the merger itself as gravity compressed some wandering cloud just tightly enough. These clusters are ancient, dense, full of low metallicity stars, the galactic equivalent of grumpy grandparents who've seen it all and refuse to move. Further out, you notice a bizarre looping structure, stars and gas arranged in a faint arc. This is called a stellar shell, and it's one of the surest signs a galaxy has undergone a merger. These shells form when smaller galaxies are swallowed, and their stars settle into repeating elliptical orbits, piling up at the edges like concentric waves in a pond. They're not obvious. You'd miss them with the naked eye, but if you point the right telescope, the ghosts appear. Arcs of light in otherwise calm elliptical galaxies. Ripples of memory. Signs of violence long forgotten by everything but the stars. You drift through one now. It's whisper quiet here. The stars move slowly, their paths almost hypnotic. No drama, just inertia. And that's the real truth of a galactic merger. Most of it isn't exciting, it's slow, predictable, a rebalancing act that plays out over unimaginable scales. You're floating through the in-between now, the part no telescope ever lingers on, the calm after the fireworks, the moment when the galaxy exhales and starts to reshape itself. Below you, the new core pulses quietly. The double black holes are still there, still circling. The starburst is fading, the gas supply dwindling. Things are starting to fall into place. And while you may not see the final moment of transformation, you're here for something equally rare. The moment the galaxy decides to be one thing again. Not two spirals, not a battlefield, but a new identity, formed from friction, patience, and gravity's unrelenting grip. The light is softer here, the motion is subtle, the stars are settling, and so are you. You're floating near the edge now, not the edge of space, not quite, but the dim outskirts of a galaxy that's finally starting to remember what stillness feels like. After all that chaos, after all the bright flashes and gravitational tug-of-wars, you've arrived at a place that feels almost quiet. And yet, something is happening here. It's not loud, it's not flashy, but it's heavy. You're witnessing the death of a galaxy. Okay, death is a little dramatic. The galaxy isn't keeling over or collapsing in on itself, but the thing that made it young, vibrant, chaotic, that furious factory of stars, it's winding down, and it's winding down fast. The supply of cold gas, that crucial ingredient for making stars, has been used up, blown out, or too thoroughly heated to form new stars efficiently. All that showy starburst activity you floated through earlier, it's over. The fuel tank is empty, the neon sign has flickered off, and the factory's shutting its doors. Galaxies don't usually go out with a bang. They fade, they stop giving birth, and the stars that already exist just keep aging, growing redder, dimmer, quieter. And eventually, a once spiral, once chaotic, once glorious galaxy becomes a puffy reddish smear of older stars, glowing faintly like embers long after the fire. Astronomers call this process quenching, not because it's refreshing, but because it snuffs out the thing that makes a galaxy feel alive. The exact mechanism isn't fully agreed upon. Some say it's black hole feedback that heats or ejects the remaining gas. Others blame the merger itself for stirring things up so much that nothing can cool down again. As usual, no one agrees entirely. Some models work for massive galaxies, some for small ones. Some galaxies keep forming stars long after mergers, others don't. It's one of those ongoing astrophysical mysteries that sits on a chalkboard somewhere, circled 3 times in red. But whatever the cause, you're watching the effects unfold. Below you, the gas is thinning. You pass through clouds that would have once crackled with birth, and now they barely shimmer. No shockwaves, no jets, no spark. The environment is too hot, too diffuse. The gas isn't collapsing anymore, it's coasting. A few newborn stars still flicker here and there, leftovers, but most of what surrounds you are stars already deep into middle age. Red giants, aging clusters, systems with no reason to expect anything new. It's like walking into a concert hall hours after the show ended. The lights are still dimmed, the air still holds a whisper of sound, but the instruments are packed up. The audience is gone. Here's a little historical side note for your sleep sponge of a brain. It wasn't until the mid-20th century that astronomers began classifying galaxies by their colour as a clue to their age. Blue galaxies are young and active, filled with hot, massive stars. Red galaxies are older, quieter, quenched. This led to the discovery of the so-called red sequence, a class of galaxies that had clearly stopped forming stars and drifted into retirement. And here's your quirky tidbit for tonight. One of the most chilling theories in astrophysics suggests that many of these quiescent galaxies, particularly the massive ellipticals, harbour so little star-forming potential that they might never make new stars again. Like ever. Cosmic nursing homes, drifting through eternity with only fading memories of their youthful chaos. But this one, your galaxy, isn't quite there yet. It's only beginning to fade. You drift past a small knot of stars, what remains of a starburst cluster. It's still warm, still blue, still loud by galactic standards. But even here, things feel brittle. The most massive stars have already gone supernova, scattering heavy elements into the now useless gas around them. The remaining stars are smaller, quieter. They'll last longer, but not forever. Everywhere you look, things are slowing down. The stars move, but not with purpose. Their orbits are still distorted from the merger. Some spin around the new galactic core in wide, lazy arcs. Others bob up and down through the halo like confused bees. There's no spiral structure to guide them anymore, just the gravitational haze of the new elliptical galaxy taking shape. You remember what it used to look like, don't you? That glorious double spiral, arms reaching, cores blazing, a dance so slow and so grand it felt like the whole cosmos was holding its breath. Now it's like watching fog settle. But don't feel sad for the galaxy. This is just a new phase, a calm one. The frantic energy of youth has passed, and what remains is something steadier, older, and, if you'll allow it, a little bit wise. You float higher into the developing outer halo. Here, the density drops. The stars are spread thin, whispering past each other in long looping arcs. You pass what might be a globular cluster, still tightly bound, still spinning, another survivor, another relic of a wilder time. And just beyond it, a surprise, a single, rogue star, speeding outward, probably slingshotted by the gravitational chaos of the black hole merger deep in the core. It could be moving at thousands of kilometers per second, fast enough to leave the galaxy entirely and head into intergalactic space, alone. These are called hypervelocity stars, and we found them in the Milky Way too, likely flung by our own central black hole. It's rare, but not impossible. One unlucky nudge, one precise angle, and boom, you're a stellar cannonball. You watch it go, blinking gently as it disappears into the dark. Then you turn back to the fading galaxy behind you. It's still massive, still beautiful, but now it's quieting, and in a few billion years, it may be nothing more than a red elliptical blob, coasting through space with its glowing past buried in stellar fossils and shell structures, a memory wrapped in starlight. And you drift on, listening to the last light echo. You're coasting now, slowly, steadily, through the ghost of a spiral. The elegant arms are long gone, shredded into light years of wispy filaments. The core is puffed up and quiet, the kind of quiet that feels permanent. Below you, this once thriving galactic body has become something altogether different. You're drifting through a post-merger fossil, a shapeshifter galaxy. Not spiral, not fully elliptical, something in between. And now you see what the violence has left behind. The first thing that catches your eye, or whatever your drifting observer self uses to perceive light, is a twisted, lopsided smear of stars bending off to one side. It isn't symmetrical. It isn't clean. It looks like someone tried to paint a spiral but ran out of energy halfway through. This is what astronomers call a warped disk. You float over it, the stars weaving under you like ripples in a disturbed pond. They're still orbiting, yes, but not in neat little circles anymore. Instead, they tilt and wobble, like a stack of plates knocked askew. These distortions can last billions of years, slowly settling, if nothing else interrupts them, and something always interrupts. Your surroundings feel tired but not dead. Not yet. Now you spot something even stranger. A loop. A soft arc of starlight rising out of the main body of the galaxy like a frozen wave. It curves back in on itself, faint but beautiful. This is a stellar shell, not to be confused with a gas shell or supernova remnant. These structures are made entirely of stars, piled up at specific points in their orbits after being flung out during the merger. Think of a galactic version of skipping rocks across a pond and seeing ripples form as each stone touches down. That's what you're seeing, the echoes of orbits. These shells are often hard to spot in a casual glance. They're dim, diffuse, and only visible if the angle is just right. But once you see one, you can't unsee it. They're the signature of a dramatic past, like bruises beneath a layer of makeup. And here's your historical science moment. Back in the 1980s, as telescopes improved and image processing got fancier, astronomers began noticing these faint arcs around otherwise normal-looking elliptical galaxies. At first, they were dismissed as imaging artifacts, but over time the evidence grew. These shells were real, and they were everywhere. That's when it started to click. Even the most peaceful-looking galaxies might have a violent backstory. You're hovering over one now, and it's strangely soothing. Stars gliding slowly along ghost paths. No gas, no dust. Just ancient light, curving like handwriting across the dark. There's something oddly personal about it, like you're reading the galaxy's diary. Just pages of motion, trauma, and very slow healing. As you drift along the outer reaches, you spot another strange structure, a tidal stream. These are long, narrow ribbons of stars, often wrapped in spirals or looping far outside the galactic disk. They're the shredded remains of a satellite galaxy that got too close and paid the price. Yes, galaxies can have satellites, just like planets have moons. And when a big galaxy merges with another giant, it doesn't always do so alone. It brings baggage, smaller galaxies trailing behind like loyal pets. But in this case, those pets get devoured too. You float along one of these streams now. The stars here are quieter, lower mass, mostly red. They're survivors, but they've been stretched like taffy by gravitational tides. It's a kind of cosmic erosion. Astronomers have spotted similar streams around the Milky Way, remnants of the Sagittarius dwarf galaxy, which we've been digesting slowly for billions of years. Yes, our home galaxy is a galactic cannibal, and you didn't even notice. Typical. You pass a compact little bundle of stars, what's left of the core of a satellite galaxy, still stubbornly hanging on, orbiting like it doesn't know it's already been consumed. There's an ongoing debate in the astrophysics community about how many of these smaller galaxies survive mergers versus how many get fully dissolved. Some simulations show clean devourings, others suggest a long, slow erosion process. Either way, what you're seeing now is a hybrid, a galaxy shaped by multiple pasts, not just the big central merger. Quirky fact time: in some rare cases, galaxies undergoing mergers develop polar rings, bands of stars and gas that orbit at right angles to the main disk. Imagine if the Milky Way suddenly had a glowing hula hoop spinning around its north pole. That's what a polar ring looks like. They're rare, they're weird, and astronomers still aren't totally sure how they form, likely from gas stripped off a smaller galaxy and captured in an oddly stable orbit. You don't see a polar ring here, unfortunately, but you do see something close, a weirdly tilted loop of stars that doesn't quite align with the rest of the galaxy. Not a ring, more like a scarf in the wind. You float further out now into the halo. It's fainter here, quieter. The stars are fewer, more spread out. You're looking at halo stars, ancient and metal poor. They likely formed early in the galaxy's life, or even before it, as part of some smaller system later absorbed. You pass a globular cluster packed tight with old yellow stars. These clusters are the elderly monks of the galaxy, quiet, self-contained, and full of secrets. Some clusters survive galaxy mergers, others don't. The ones that do tend to orbit far from the core, like this one, untouched, untamed. Above you, the light dims further. The edge of the galaxy is near. You look back. The main body is smooth, elliptical. The starburst is over. The disks are shredded, but the bones remain. It's no longer two galaxies. It's one, warped, shredded, bruised, rebuilt, but one. And like all things shaped by conflict and time, it's somehow more beautiful for it. You're drifting slowly through the twilight zone of the galaxy now, beyond the core, past the shredded remnants of arms and the tidal leftovers. You're so far out that the main galaxy behind you is starting to look like a single glowing blotch, dimmed by distance and time. This is where the galaxy's influence begins to blur, where its grip fades and things start to fall apart, or float free. Welcome to the debris fields. You might have expected this place to be empty, a cosmic backyard with a few forgotten rocks, but it's far stranger than that. Because even though the dramatic parts of the galactic collision are behind you, not everything found a home in the new structure. Some stars didn't get absorbed, some gas clouds refused to settle, some systems were flung so far they became wanderers, never to return. And now you're among them. The first thing you pass is a lonely star system, gliding on a trajectory that points nowhere in particular. It doesn't orbit the new galactic core. It doesn't belong to any remnant arm or shell. It's just floating, quietly, as if it slipped through the cracks of the merger. This is a stripped system, ejected during the early tidal exchanges. It might once have lived near the edge of one of the spirals, back before everything collapsed inward. But the chaotic pull of gravity during the initial collision gave it just the right or wrong shove, and now it drifts, not fast, not lost, just unclaimed. Nearby, a faint cloud of gas pulses softly in the infrared, still too cool to ignite into stars, but dense enough to glow. It's a tidal dwarf candidate, a blob of material torn from the original galaxies, possibly bound tightly enough to form a new galaxy of its own someday. That's right. Mergers don't just destroy. Sometimes they create again, but in weird places, with leftover parts. There's an actual example of this happening. In the Antennae Galaxies, one of the most iconic mergers ever captured by telescope, astronomers have spotted several dense clumps of gas in the tidal tails, potentially forming new dwarf galaxies like cosmic barnacles growing off the hulls of colliding ships. You glide toward a similar clump. It's lumpy, unstructured, barely more than a suggestion of a galaxy. But there's gravity here, motion, a whisper of future identity. And here's the quirky bit. These tidal dwarfs are usually rich in heavy elements, unlike most small galaxies, which tend to be metal poor. Why? Because they're built from the used parts of bigger galaxies, recycled gas, stars with history. They're like hand-me-down galaxies, full of character, slightly haunted. Above you, a small group of stars twinkle, moving in formation. Not a cluster, too diffuse, more like a drifting gang of misfits. Some of them are runaway stars, those ejected at high speeds from the core during the black hole dance. Others might have simply been in the wrong place when a tidal tail snapped like a whip. They don't know where they're going, but they're going fast. And now, finally, you pass into the strange no man's land between galaxies, a zone where gravity's hold weakens but never truly lets go. Here, you find a rare and eerie phenomenon: intergalactic stars. Yep, stars that don't belong to any galaxy, just out here, drifting across the cosmic void. Astronomers have confirmed their existence by studying intracluster light, a faint glow found in the space between galaxies in massive clusters. It turns out some of the stars that get stripped during collisions, like the one you've been watching, don't end up in the new galactic halo. They get tossed clean out. And since gravity in deep space is subtle but relentless, these stars can coast through nothingness forever, lighting up a part of space we once thought was truly empty. You glide past one such star now. It's red, old, probably on the tail end of its life. Maybe once it belonged to a satellite galaxy or a globular cluster. Maybe it orbited close to one of the black holes before being ejected in a gravitational slingshot. Now it just burns quietly, with no starry neighbours, no planets, no name. There's something poetic about it, but also lonely. Even galaxies don't keep all their pieces after a merger. As you drift deeper into the debris field, you notice the shape of the galaxy behind you has softened even more. From this distance, it looks like a cottony smear. No arms, no shells, just a faint glow. The merger is done, the healing has begun, but not everyone made it back. Above you, a diffuse stream of gas curls like smoke, trailing out into the dark. Maybe it'll cool enough to form stars, maybe not. For now, it just is, a reminder of the energy that got left behind. And down below, moving so slowly you'd never notice unless you really stared, is a faint, stretched out system of stars, another shredded satellite. It's the remains of a galaxy that wasn't part of the main collision, but got too close at the wrong time. It's being digested slowly, like dessert after a very messy meal. Astronomers call these long, narrow leftovers stellar streams, and we've seen them in our own Milky Way. The Sagittarius stream, the GD1 stream, trails of stars wrapping around us silent as ribbons, telling the story of a 1,000-million-year feast. You're watching one now, tracing its slow arc across space. Some stars will fall into the main galaxy's gravity and settle. Others will remain outside, hanging like thread around the edge of a blanket. Neither here nor there, just still moving. There's a strange serenity to all this. The chaos is over. The loud parts are done, but the aftershocks continue, slow, wide, and permanent. You float higher still, far enough that the new elliptical galaxy, once two spirals, is just a smudge. The trails around it like cracks in old glass. The debris field spreads around it like mist. The light is low, the motion is slow, but everything here tells a story of stars flung, of gas forgotten, of galaxies half-eaten and shells formed from the stretching of stellar skin. Nothing in space gets cleaned up. Everything stays. You're far from the centre now, so far that the galaxy barely glows behind you. Its edges shimmer faintly like a dying campfire, and the stars scattered throughout the halo and debris field blur into points. Soft amber glimmers against the black. But even out here, where the galaxy's voice is quieted to a whisper, something gentle pulses. a kind of deep space exhale. You feel it in the subtle arcs of orbiting stars, the gradual cooling of gas, the slow drift of structures too far to care about what's happening at the core. This is what it means when giants sleep. The galaxy has settled into its new form, a vast elliptical mass with no arms, no central bar, no cold gas spiralling inward to feed a starburst. It's older now, heavier, and you, sleepy traveller, are watching it enter a long twilight. The stars remaining are mostly older, yellow and red, drifting with all the speed and enthusiasm of dust motes in a late afternoon sunbeam. No new stars are forming here. Not really. There's no fuel left, no shock waves, no heat in the right places, just old stars cooling in old orbits. And here, in the galaxy's slow fade, you begin to feel it too. The silence, the stillness, the long pause between heartbeats that stretches on forever. You float through one final gas cloud. A ghost of a cloud, really. Too thin to do anything useful. Too scattered to collapse. It glows faintly in infrared, like the warmth left in a cup long after the tea is gone. And it drifts, as you do, pulled ever so gently by the gravity of the whole. You pass one last cluster, a tight ball of ancient stars wrapped in a dark halo of nothing. These globular clusters are survivors, older than the merger, older than the galaxies themselves in some cases. They orbit far from the core, silent companions to the galaxy's slow transformation. One star blinks as you pass, a red giant at the edge of its life. Its outer layers puff and swell, slow and luminous. Soon it'll shed them entirely and shrink into a white dwarf, a glowing ember in space. It will cool over billions of years, fading imperceptibly until it becomes a black dwarf. If the universe lasts long enough for that to happen, which it probably won't. But that's a different bedtime story. As you move deeper into the halo, the galaxy begins to disappear behind you. Not in a dramatic way, just softly. The light thins, the stars space out. You're entering the edge of what counts as somewhere in the universe, and then beyond. Here, the galaxy's pull is faint, but it's never gone. It whispers to the stray gas clouds, to the runaway stars, even to you. This, in cosmic terms, is what finished looks like. The starburst galaxy has become an elliptical, a red giant of a system, quiet, still, complete. You pass one more relic, an orphaned black hole, a small one. Maybe it came from a swallowed satellite galaxy, or it was ejected during the black hole dance at the centre. It doesn't matter now. It floats alone, invisible except for the slight lensing of background starlight. It hasn't eaten anything in ages. You nod to it, if one can nod in zero gravity, and move on. The temperature out here is barely above absolute zero, but it's not hostile, it's peaceful, it's the kind of cold that feels like sleep. And you realise now, you've watched something enormous die, or rather, change. Galaxies don't really die. They just evolve into forms that can no longer create. They glow, they pulse, they orbit, and then they don't. And back in the 1990s, astronomers coined the term red and dead to describe galaxies like this. Massive ellipticals with little to no star formation. At the time, it was a bit cheeky. Now, it's practically official. Galaxies that went through dramatic mergers early in the universe's life, and then faded into crimson silence. And yet, these galaxies shine. They dominate the galaxy clusters. They light up space in infrared and radio waves. They're just not interested in making new stars anymore. They've seen enough. You hover for a moment longer, letting the glow of the galaxy drift behind you, dimming slowly. In a few billion years it'll look much the same from here, and in a few billion more, maybe different. But you won't be here to see it. No one will. Still, you watched it happen. From the first gravitational pull to the final stretch of silence, from spirals to chaos to stillness, from everything to one. The universe doesn't do closure, but it does do balance. Now let yourself drift backward. past the final streams of stars into the dark that surrounds all things. It's quieter here. Even gravity takes a pause. You're safe, you're warm somehow, and the story is over. Let's slow down now. Let the final glow of the galaxy fade into the black. Let the last stars shimmer, then blink out in your peripheral vision. Let the silence wrap around you like a blanket of cosmic dusk. You've seen a galaxy collide, transform and rest. So rest too. Float softly. Breathe slower. There's nothing more to chase tonight. You stir slightly, floating in the dark that swells around the now sleeping giant behind you. But ahead, ahead is something dazzling. Because while you've just watched one galactic drama from the inside, you're about to watch many from afar. Welcome to the Hubble tapestry. You're drifting past the edge of familiarity now, your gaze widening, refocusing. And suddenly, there it is. A spread of galaxies painted across the black canvas of space, each one paused mid-movement, frozen in light that's taken hundreds of millions, even billions, of years to reach us. They're not simulations, not illustrations. These are real galaxies, really colliding, really warping and twisting themselves into knots, all captured by the eyes of the Hubble Space Telescope. You glide into the heart of the gallery. To your left, two galaxies with bright looping arms like tangled headphone cords caught in a drawer. You recognize them, the antennae galaxies, one of the most iconic colliding systems in the observable universe. They're caught mid-embrace. Long, thin tidal tails stretch out in opposite directions, made of thousands of stars flung away during their violent dance. At their centers, dense clouds churn with star formation, those furious starburst nurseries you've seen up close, now glowing softly from afar. You drift sideways, and there, twisting like a spiral staircase dipped in gold, is NGC 4676, better known as the Mice Galaxies. Another cosmic couple, sliding past each other, their tails flaring out behind them like streamers. They look delicate. They're anything but. Each of these galactic wrecks has taken place over hundreds of millions of years. And thanks to telescopes like Hubble, Spitzer, and now James Webb, we've captured them in slices, snapshots of time, each one frozen just long enough for us to pretend we understand what we're seeing. You pass NGC 7252, sometimes cheekily nicknamed the Atoms for Peace Galaxy, because it resembles the atomic symbol. It's a massive post-merger system with brilliant loops of stars forming perfect, ghostly circles around a glowing core. It looks serene, balanced, like something that was meant to happen. But you know better now. You've seen the war that came before, you've drifted through it. Here's your history fact. Hubble didn't just show us galactic collisions, it proved them. Before high-resolution imagery, galaxy mergers were mostly theoretical, supported by math, simulations, and a handful of blurry images. But when Hubble started delivering those crisp, high-contrast shots in the 1990s, the debate changed. It was no longer about whether galaxies collided. It became about how often, and why, and what came next. Astronomers started cataloguing mergers like birdwatchers, tidal tails, warped disks, shell structures, double cores. Each feature became a clue. The Tumor sequence was born, a collection of merging galaxies ordered like a flipbook, showing the stages from first contact to final coalescence. It was part science, part art, and all utterly mesmerizing. And quirky fact time. The Tumor sequence was originally based on computer simulations in the 1970s, using cutting-edge tech that, by today's standards, wouldn't power a smart fridge. Yet those early models nailed it, predicting features we now see in actual galaxies decades later. Turns out gravity doesn't need a fast processor, just time. You pass another frame in this gallery of wreckage, ARP 273. Two galaxies, one larger and more distorted, the other looping above like a sibling pulling at a scarf. Their shapes are almost floral, spirals bent into petals by mutual gravity. It's strangely elegant, the kind of image that makes astronomers sigh and artists cry a little. And now, look deeper. Behind these luminous duets, scattered like glitter across velvet, are hundreds of distant galaxies. Smaller, dimmer, some are merging, others are untouched. Some are just beginning to spiral, others are fading, and every single one of them is old. The light from these systems started its journey before humans ever picked up a rock or drew on a cave wall. Some left their galaxies before Earth even existed. You're not just watching space, you're watching time. Each glowing smear is a history book, a fossil, a slow-motion explosion caught in stasis. And here's the kicker. These collisions you're seeing, they're normal, not rare, not unusual. Most galaxies in the universe have gone through some version of this. Ours included. Future ones will too. You're not seeing oddities, you're seeing the way of things. Somewhere down there, among the lights and tails and twisted arms, you spot a familiar shape, a flat spiral, viewed edge-on, with a small satellite galaxy orbiting near its edge. That's the Milky Way, and that small, flickering companion? That's the Large Magellanic Cloud, one of several dwarf galaxies caught in our gravitational field. We've already begun our own dance, slowly, invisibly, but surely. The Andromeda Galaxy, another spiral roughly the same size, is on its way. It's faint here, just a shimmer, but it's coming. You'll feel the pull eventually. That story, it's coming up, but not yet. For now, you coast through this museum of cosmic violence, this frozen ballet of collision and coalescence. Every system here tells the same story in a different dialect. Two galaxies meet, they distort, they warp, they burn, and then they become something new. You drift further through the Hubble tapestry, letting the stars blur, the shapes melt, the colour shift from violent blues to softer reds. You blink, again metaphorically, and the whole sky looks like it's still moving. Because it is. You're still gliding through the tapestry, but the pace has shifted. You've pulled back so far, so gently, that everything seems to slow to a crawl. Even the chaos, even the light. The galaxies you see now are frozen in the middle of vast, elaborate dances, and not just one or two, but dozens, hundreds, maybe thousands of them, each one nudging, pulling, spiraling, colliding. It's beautiful, it's overwhelming, and it's happening in slow motion. That's not a metaphor, it's the reality of cosmic time. Galaxies move fast, thousands of kilometers per second, but they're so massive and so far apart that even the most dramatic interactions take millions or billions of years to play out. You're watching the universe shift in units so large, you'd need geological patience just to follow a single step. Right now, you're floating over a pair of spiral galaxies at the earliest phase of a collision. They're still far apart, hundreds of thousands of light years, and yet the pull has already begun. Their outer halos are brushing against each other like fingertips testing the surface of water. To the casual observer, it would look like nothing's happening. But you've got the perspective now. You've seen the end game. You know what these delicate tugs will eventually turn into. The galaxies themselves probably don't even know yet. Which is funny if you think about it. Like watching two people at opposite ends of a crowded room glance at each other, unaware they'll be married in 20 million years. You hover, watching it all unfold. This part of the story is often overlooked. The slow lead-up. The gravitational flirtation. Most people think of galactic collisions as bang-bang, smash-smash. But the truth is, the approach takes just as long as the aftermath. And the signs are already there. You see faint warps in one of the spiral arms. A small cloud of stars being drawn out toward nothing. A subtle increase in star formation at the outer rim, like goosebumps on a galaxy's skin. It's all starting. Let's pause for a moment on one of those distant galaxies, maybe NGC 2207 and IC 2163, a pair of spirals caught in a dramatic slow entanglement. They're close enough now that gas is flowing from one to the other, not like a waterfall, more like syrup between pancakes. The tidal forces are already pulling out long streamers of stars. This is called a bridge, a luminous connection made of matter literally torn from one galaxy and handed over to the other. You float across it now, gliding between stars that were never meant to live here, each one flung into this cosmic causeway by the invisible hand of gravity. Further along, a faint tail, a counterweight, drifts out in the opposite direction, balancing the bridge like a long strand of trailing light. The galaxies are stretching, bending, slowly giving in. This slow ballet has been modelled in computer simulations for decades, and here's a historical nod. The first major numerical simulations of galaxy collisions were run in the early 1970s by brothers Alar and Juri Toomre. They used stars represented by dots and gravity calculations that, at the time, were cutting edge. The results? Shockingly accurate tidal tails, bridges, even predictions about how the galaxies would merge. Today, we run the same simulations on supercomputers with millions of particles, gas physics, and dark matter halos included. But the principles haven't changed. Gravity is still calling the shots, still the composer behind this vast, slow-motion symphony. And here's a quirky little nugget for you. Some scientists think you could describe galaxy mergers with musical terms: tension, crescendo, resolution. One team even tried to sonify galaxy collisions, turning data from simulations into music. Turns out, gravity has a rhythm. It's just too slow for you to tap your foot to. Unless your foot is made of mountain ranges, and your heartbeat only fires once every 100 million years. You pass another galaxy, NGC 4038, the companion to one of the antennae galaxies. You saw it earlier in the throes of collision, but here you catch it earlier in time, before the chaos. The arms are still intact, though there's a subtle spiral thickening, a hint that things are shifting inside. Galaxies rarely collide alone. They live in clusters and groups like cosmic neighbourhoods, and sometimes these group interactions set off chain reactions. One minor collision triggers another, then another. You get compact groups, like Stefan's quintet, where 5 galaxies are squeezed into a tight region of space. Only some are merging. The others are innocent bystanders, at least for now. You watch one of those innocent galaxies arc away, pulled slightly off course. It might escape, it might return. In space, even goodbye isn't always permanent. Now, as you float through this dense gallery of motion and tension, the scale of things starts to dissolve. Galaxies look like dust. The interactions feel like water. It's hard to believe anything here is made of hundreds of billions of stars, but they are. Every smear, every loop, every ribbon. You've pulled back so far that the collisions don't look violent anymore, just inevitable, like wind-shaping dunes. And yet, you know the truth. Inside each of these systems, there are stars being flung, gas clouds being crushed, black holes spiraling, planets being lost, star clusters evaporating, dust warming. It's all in there, behind the slowness. You pass one final pair, tiny, almost insignificant from out here. Just 2 fuzzy dots, drawing toward each other over the span of 1 billion years. You won't be around when they finally touch. But that's okay. Galactic collisions aren't meant to be watched all at once. They're meant to exist, to carry on long after you're gone. You turn slowly in place, letting the cosmic pageant drift around you. Every galaxy a slow-moving dancer. Every merger a duet without applause. The motion continues, soft, relentless, eternal. The slow ballet of galaxies continues around you, but now you're pulled, not by a star or a planet or even a black hole, but by something deeper, something more mysterious, something you can't see, can't touch, and can't escape. You're floating through the invisible architecture of the universe itself. This is the realm of dark matter. And yes, it's here, everywhere. You've been floating through it this entire time. Every galaxy you've watched merge, every spiral that wrapped itself into a knot, every burst of newborn stars, it all happened within the soft gravitational well of dark matter. It's the skeleton inside the skin of every galaxy. But from out here, You see it differently. You're not just floating through one galaxy's halo anymore, you're coasting along a cosmic scaffold, the dark framework that binds galaxies into clusters, clusters into superclusters, and superclusters into filaments that thread through the entire visible universe like cobwebs made of gravity. It's beautiful if you know where to look, which admittedly is a challenge, because dark matter is invisible. No light reflects off it. It emits nothing, but its presence, its presence is everywhere. You drift through one of these vast ghostly halos now. Around you, faint stars, halo stars, satellite galaxies and loose debris still follow its gravity, as obedient as marbles in a tilted bowl. And it's massive. By our current understanding, dark matter makes up about 85% of the universe's total matter. That means everything you've actually seen so far, the stars, gas, dust, planets, is just the tiny, glittering tip of an unimaginably large invisible iceberg. Let that sink in. Everything you've ever considered real in space, the beautiful parts, the bright parts, the parts captured in telescope photos, is barely 1/6 of what's actually there. Now here's your historical fact for the night. The concept of dark matter was first proposed in the 1930s by Swiss astronomer Fritz Zwicky. He was studying the Coma cluster and noticed that the galaxies inside it were moving far too fast. According to Newtonian physics, they should have flown apart. The only way they could be held together was if something, some invisible mass, was exerting gravitational force. Zwicky called it dunkle materie, dark matter. Most of his peers thought he was off his rocker, but like many eccentrics, it turned out he was just early. It wasn't until the 1970s, thanks to the work of Vera Rubin, that dark matter got real attention. She observed spiral galaxies and found that the stars on the edges were orbiting just as fast as the ones near the centre. Again, something that shouldn't happen unless there was more mass than we could see. And thus the modern obsession with dark matter began. You pass through the heart of one such halo now, a bubble of gravity large enough to hold a galaxy cluster together, yet perfectly invisible. Except it's not totally invisible, not if you know the tricks. You look to your left, where the light from a distant galaxy warps and bends into a smeared arc, like someone dragged a finger across wet paint. That's gravitational lensing. The dark matter between you and the background galaxy is bending space-time, curving light itself and turning the image into a twisted mirage. It's one of the few ways we can see dark matter's fingerprints. And it's spectacular. You glide past another lensing arc, and another, a cluster of warped galaxies, distorted into rings and streaks. These are called Einstein rings, and they're perfect cosmic accidents, moments when light, mass, and geometry align just so. You're watching space itself be folded. Quirky fact time. Some galaxy clusters are so heavy with dark matter that they act like cosmic telescopes. Their gravity can magnify the light of distant background galaxies, allowing us to see things far, far older and farther than any normal telescope could reach. In a strange way, dark matter is helping us see the past. But here's the mystery. We still don't know what it is. Seriously, after decades of study, thousands of papers, supercomputers running endless simulations, we still have no idea what dark matter is made of. WIMPs, axions, sterile neutrinos, modified gravity. Pick your theory. They're all on the table, and none of them have been definitively proven. The debate is still raging, and the detectors are still waiting. What we do know is this. Without dark matter, galaxies couldn't form. They couldn't merge. They couldn't even hold themselves together. You're floating inside the real power behind every galactic collision you've watched. The hidden hand, the framework, the reason things fall, crash, and reshape, the reason stars spiral instead of scatter, the reason galaxies survive their own chaos, and the reason your sleepy little tour tonight has meaning. You move further along the dark web now, past clumps of invisible mass, past faint galaxies still locked in their halos, past gravitational currents you can't see but can feel. Somewhere ahead a new collision is starting, Somewhere behind, an old one is still fading. But here, in this invisible bridge between them, you understand something essential. The universe isn't built on what we can see. It's built on what we feel, pulling at everything all the time, everywhere. You drift onward, weightless, wondrous, held in place by the shape of what isn't there. You're floating now at the soft, dim edges of where a galaxy used to be, at least where its main body used to live. All the gas and stars and black holes have done their chaotic dance, merged, settled, and grown quiet. But not everything was absorbed. Out here, in the space between galactic certainty and intergalactic drift, lies what can only be described as cosmic fallout. Welcome to the intergalactic debris fields. This place feels different, not empty, just unclaimed, detached. You're no longer surrounded by the dense star fields of a galactic core or the looping elegance of tidal tails. Out here, everything feels like it's trying to remember what it belonged to. And most of it never will. The first thing you pass is a faint shimmer, a barely there cloud of neutral hydrogen gas. It's cold, it's slow, it's silent. It was once part of a spiral arm, perhaps, but during the collision it was flung out, tugged away from the gravitational safety of the galaxy. These clouds are everywhere in the aftermath of mergers, HI clouds, as astronomers call them. They float through galactic outskirts like fog on a forgotten battlefield. If they're lucky, they'll clump up again, maybe even birth stars. If not, they'll just keep drifting, unformed, undone. You reach out, metaphorically, and move through one now. The gas is thinner than the best vacuum ever made on Earth, but it's still there, clinging to existence. Every now and then, a rogue cosmic ray zips through, like a pinged text message in the dark. And then, something brighter. A rogue star, just one. A tiny sun, burning alone in the dark. It's speeding along on a path that leads to nowhere. Flung out during the merger, when gravitational chaos turned the centre of the galaxy into a slingshot. Some rogue stars are small. Others, giants, even supergiants. All of them are travelling fast enough to escape the galaxy's gravitational pull forever. These are the runaways, galactic exiles with no starfield to call home. Our own galaxy has a few of these. One, discovered in 2005, is moving at over 800 kilometers per second and likely originated near the Milky Way's central black hole. That's fast enough to leave our galaxy completely, a true intergalactic traveller. Maybe one day it'll pass near Andromeda, or what's left of it. You drift past a cluster of them now, rogue stars caught in similar arcs, flung together but each travelling alone. There's something almost sad about it. Stars are usually social creatures, born in clusters, moving in groups. But here, they're solitary, silent, and still they shine. Below you now, a gas ribbon curls like a jellyfish tentacle in zero gravity. It's a remnant of a tidal tail, once thick with star-forming regions, now just an echo. But don't let the stillness fool you. This gas could still do something. Given the right trigger, maybe the passage of another galaxy, or a high-speed shockwave, it could compress and collapse. You'd be looking at a newborn tidal dwarf galaxy. Again, not rare. These kinds of galaxies form in the outskirts of major mergers more often than you'd expect. They're small, yes, but they're real. Gravitationally bound, self-governing, and made entirely from the stolen parts of bigger systems. In a way, they're the orphans of cosmic conflict. Galaxies born not from quiet collapse, but from leftovers. You fly past one now. It's small, lumpy, uneven, but stars twinkle inside. Blue-white, hot, fresh. It's alive. And then, beyond it, something even weirder. A lone globular cluster, orbiting nothing in particular. It was probably pulled out of its parent galaxy during the final merger stages and never found its way back. Now it just drifts. An ancient ball of stars with no host. Astronomers have found several such objects. Some even theorize that many isolated globular clusters out in the void are fossils of long-vanished dwarf galaxies, stripped down to their dense cores by bigger, meaner galaxies over billions of years. You drift by it slowly. The stars are old, yellow, packed tight, like a miniature galaxy that decided to downsize and move off-grid. And here's a little historical flavour. In the early 2000s, deep sky surveys began picking up diffuse light around galaxy clusters. Not from any one galaxy, but spread between them. This was intra-cluster light, and it turned out to be made of stars ripped from their homes during countless collisions, now roaming the void together. They're not in galaxies, they're not in clusters, they're just in between. You're watching that now. A sea of starlight too faint to be noticed in isolation but undeniable en masse. It stretches like a quiet glow between more massive structures, like cosmic pollen caught in a breeze. And here's your quirky tidbit for tonight. In 2020, a team using the Hubble Space Telescope managed to detect red giant stars inside this intra-cluster light, proving that these stars can survive, shine, and even be studied outside the bounds of galaxies. You don't need a spiral arm to be important, apparently. Floating here, among the unclaimed and the unanchored, you feel the full strangeness of galactic collisions. Because yes, there are beginnings and endings, but there's also so much that just slips out the side, and the universe doesn't sweep. Out here the rules are looser, the paths are longer, everything just keeps going. Even gravity lets go a little. You hover near a slow-moving gas bubble, barely glowing, barely holding together. Its shape isn't spherical, it's not a nebula, it's just remnants, like fog that refuse to settle, and inside it, maybe a single, tiny star, maybe a planetary system with no sun, maybe nothing at all. But it's still moving. Everything is. Even debris follows a path. You let yourself drift with it for a while. No destination, no structure, just motion. This is what it looks like when a galaxy ends but doesn't vanish. It just spreads out, fades and disperses, not into nothing, but into everywhere else. Out here, where the starlight is faint and the paths uncertain, you begin to sense the weight of what comes after. The aftermath of a galactic merger doesn't just leave chaos in its wake, it reshapes the entire identity of the galaxy itself. The slow settling, the reorganization, the strange, weary calm. This is where the giants go to sleep. Below you now is the heart of the newly merged galaxy. The chaos has passed, the tidal tails are flung, the gas is mostly spent. The galaxy no longer burns with youthful blue starbursts or flares of colliding gas. It doesn't spiral, doesn't twist. It simply sits, massive, round and glowing with the amber light of old stars, an elliptical galaxy, born from violence. The final form of two former spirals, now one. From this distance it looks deceptively serene. A glowing sphere of starlight with no edges, no arms, no urgency. If you didn't know better, you'd call it peaceful. But you do know better. You've seen what it took to get here. The once dynamic disks have been erased. Stars that used to orbit in neat circles now follow random, intersecting paths like bees in a windstorm. There's no organised motion anymore, just velocity. Every star doing its own thing, held loosely in place by the galaxy's enormous gravitational mass. You pass through the outer envelope of this sleeping giant, and the stars here are sparse, slow, old. Redder than the stars you remember from the earlier stages. Many of them are nearing the end of their lives. Some are already dead. White dwarfs cooling into silence, neutron stars pulsing faintly with ancient magnetism, black holes invisible except to those who know what to feel for. This galaxy is now a monument to longevity. It won't form new stars. There's no cold gas left to trigger fresh collapse. Everything that could ignite already has. The bright blue of youth is long gone. What remains is gold, crimson, and deep, slow orange. You float near the edge of a globular cluster that orbits like a distant moon. The stars here are so tightly packed they almost blur into one another. This cluster predates the merger. It has survived more than one cosmic reshuffling, and it'll keep orbiting until gravity finally gives up, which may be never. There are hundreds of these clusters, orbiting far out in the galaxy's halo like loyal satellites. They hold memories of what came before. Their ages can be measured in billions of years. Their chemistry is low in metals, rich in hydrogen, and perfectly suited to outlast the chaos. Historians, astrophysicists, still debate how many of these clusters are native to the original galaxies and how many formed because of the merger. There are models that suggest mergers trigger the formation of new globular clusters from shocked gas. Others argue they're mostly stolen from absorbed dwarf galaxies. As usual, the universe refuses to give a straight answer. Beneath you now, in the galaxy's core, the black holes have likely merged. It happened long after the stars settled and the shells dispersed. Two giants spiraled inward for millions of years, whispering gravity into the void until finally, inevitably, they became one. And now, at the heart of this elliptical galaxy, there's a single supermassive black hole. Larger than either of the originals. It may spin, it may pulse, it may even release low-energy jets from time to time if there's still a trickle of gas left to consume. But mostly, it sleeps. You pause for a moment in that core, hovering just above the event horizon. You can't see it, of course, but you feel the tension, the way the stars curve around this invisible centre, how the light bends. Even here, with the galaxy at rest, gravity keeps humming. A low lullaby in the fabric of space. You float outward again, through the puffed-up body of the elliptical. The stars no longer follow any spiral logic. Their paths are chaotic but stable. Every orbit like a fingerprint. Unique. Irreproducible. This is what violent relaxation leads to. A randomized statistical calm. It sounds like an oxymoron, but that's the universe for you. Chaos that becomes balance. War that becomes sleep. And the size of it? Enormous. Elliptical galaxies formed from major mergers are among the most massive in the cosmos. Hundreds of billions of stars. A halo stretching for hundreds of thousands of light years. They may look like simple blobs from afar, but don't let that fool you. These are cosmic fortresses. Fun fact, some of the largest known galaxies in the universe are elliptical. One prime example, IC 1101. This thing stretches over 400,000 light-years across and contains trillions of stars. It sits at the centre of a galaxy cluster like a sleeping god. And how did it get so big? You already know the answer. Mergers. Over and over again. Ellipticals are born in war, but they age into kings. You drift now to the edge of the halo, the light behind you softening like sunset through gauze. This galaxy is quiet, but it's not done. Not really. Galaxies don't die. They fade. They wait. Somewhere in some distant time, another spiral will drift too close. Another dwarf galaxy will be pulled in. The halo will stretch, the core will stir, and the giant will wake again. But not tonight. Tonight it slumbers, massive and undisturbed, glowing with the last warmth of stars long past their prime. You turn slowly, letting the light fall away behind you. The galaxy grows smaller in your field of view. It doesn't vanish. It never does. It simply becomes one more shape in the background, one more whisper in the infinite dark. And you, drifting quietly through the stillness, are part of its memory now. You turn now, not by choice, but as if pulled by some quiet cue you didn't know you were listening for. The galaxy behind you fades gently into the distance, a soft golden blotch suspended in the dark. Ahead, something pulses faintly, familiar but not quite close, because it's happening again. Not one, not two, but countless galaxy collisions. Not theoretical, not ancient and done, but still happening right now all around you. The sky is full of motion, always has been. You were just too zoomed in before, too focused on the drama of a single pair. But once you zoom out and float in just the right silence, you begin to feel it. The whole universe is a collision in progress. Everywhere you look, galaxies are caught mid-step. Some are brushing halos, others are midway through. Some are on their first pass, others on their fifth. And a few, just barely, are starting to wake from sleep and stretch back toward fresh chaos. You glide past a spiral galaxy with one warped arm, gently tugging toward an unseen companion. This is Prelude, the early flirtation. Tidal distortions, rising star formation, a future already decided but not yet unfolded. To your left, a dwarf galaxy is being absorbed by a larger one, like a snowball melting into a warm hand. Not a merger exactly. This is galactic cannibalism, a slow digestion. And it's not rare, it's how big galaxies grow. In fact, the Milky Way has devoured more than a dozen smaller galaxies in its lifetime, and it's not done yet. You float upward, if directions even exist out here, and spot a more dramatic scene. Two galaxies midway through merging, their disks distorted into S-shapes, cores twisting around each other like vines in wind. From afar they glow gently, but you've been there. You know what's happening inside, gas clouds crashing, stars being flung, black holes circling like sharks, and then, just past them, another. A collision that finished eons ago, leaving behind a fat elliptical, still glowing from the last of its heated gas, its arms long forgotten. It hits you now. This is the universe's default state. Not peace, not isolation, but motion, merger, change. And most of the time we only get to see the movie in still frames. That's what makes Hubble, Webb, and all those deep sky surveys so strange and powerful. They're not just pictures, they're time machines. Each galactic collision you've seen in those beautifully lit images, it's still happening. You're just watching the first few acts with the finale still billions of years out of reach. You float closer to a galaxy cluster now, a tight tangled web of hundreds of galaxies, locked together by a vast common dark matter halo. Here, collisions are even more common. Gravity in this place is aggressive. You spot one system, two galaxies forming a single bright bar, like a figure eight caught mid-twist. Another galaxy, further in, is being stretched into a smear by tidal forces so strong it's barely holding shape. It won't survive the century, galactically speaking. Here's your history moment. As early as the 1920s, astronomer Edwin Hubble noticed that certain galaxies were strange, asymmetric, interacting. But it wasn't until the 1950s and beyond that we began to understand the scale of it. That these weren't rare cases or curiosities, they were normal. In fact, galaxies that have never collided with another, they might not even exist. If they do, they're hiding in the deep voids, lonely, isolated relics untouched by time or gravity's meddling hand. But you're not in a void now, you're in the middle of it all. You drift past a region of faint stretched arcs, not galaxies themselves, but the trails left by their stars, long lines that mark where things used to be. Like footprints in snow after the dancers have left the stage. They curve and curl, sometimes meeting, sometimes wandering off alone. They're fossil trails, evidence of motion, of closeness, of parting. You pause over one such arc. It loops gently through the black, a tidal tail with no galaxy at either end. Maybe the cores were destroyed. Maybe they've long since settled into something new, but the light remains, telling a story no one asked it to keep. Here's your quirky fact. Even though galaxy collisions are often described as violent, they're not explosions in the way we think of them. The stars rarely collide. The real drama happens in slow pressure shifts, gravitational waves and reshaped orbits. The fireworks are subtle, infrared glows, long arcs, and the hush of cooling gas. You've already seen this, felt it, and now, everywhere you look, it's happening again. There's no now in cosmology, only overlapping pasts. The galaxy you see exploding in blue light. That happened 600 million years ago. The one with the long tail still forming? That's from 1 billion years back. The quiet, elliptical, glowing red nearby. It's from a few 100 million years earlier still. Each one is a ghost, a freeze frame, a single frame of a film still unfolding behind the curtain of time. You drift back into the dark between clusters and let your eyes, so to speak, adjust to the pattern. Not just of galaxies merging, but of merging as a rule. It's built into the very structure of the cosmos. Gravity pulls, motion obeys, and sooner or later, all things touch. You glance back toward the one you followed earlier, the giant now at rest, stars cooled, arms forgotten. It was one story, one loop, one piece of the pattern, but there are millions more. Each galaxy you pass is a verse in the poem, each merger a line, each rogue star a quiet rhyme drifting between the stanzas. You're not floating through aftermath anymore. You're floating through always. The universe doesn't pause, not really. And now, at last, you see the pattern. Not just galaxies merging, not just stars flung or gas clouds compressed, not even the majestic tidal tails or the eerie shells or the warm golden glow of the aftermath. No, what you're seeing now is something bigger than all of it. You're seeing a universe in collision. You drift, slower now, not because you have to, but because it feels right. You're watching the large-scale structure of the cosmos itself. Galaxies aren't sprinkled randomly. They cling to filaments of dark matter, sprawling across the void in a cosmic web that stretches for billions of light years. And where those filaments intersect, clusters, and where clusters gather, superclusters. And within those superclusters, mergers, collisions, transformation. It's been this way since the beginning. You pause at the edge of a massive galaxy cluster, hundreds of galaxies packed into a volume only a few million light years across. From this perspective, it looks like a bustling city at night, every light a different galaxy, every street a gravitational path waiting to be walked. This cluster, like all the others, is evolving. Smaller groups fall into it. Galaxies spiral toward its heart. Gas is stripped. Shapes are warped. You watch as two large ellipticals begin their slow spiral, the precursor to a future collision that will form an even bigger, brighter galaxy. It will take 1 billion years, give or take. You've got time. You pass through the center of the cluster now. It's hot here, not in temperature you'd feel, but in X-rays. The space between galaxies is filled with superheated gas, millions of degrees, glowing in high-energy light. Not from stars, but from friction, motion, compression. This gas used to belong to galaxies, ripped away by gravity, now part of the larger environment. It's the atmosphere of a galactic metropolis, and buried inside all of this, down in the quiet core of the cluster, is a brightest cluster galaxy, or BCG, massive, elliptical, formed from hundreds of past mergers. It has no memory of its spiral origins, no arms, no bar, just mass, and light, and gravity. And at its center, a supermassive black hole so large it could swallow our solar system whole and still be hungry. You hover above it. It's not feeding right now, just spinning, quiet, waiting. Every so often it erupts, launching jets that stretch tens of thousands of light years, clearing out gas, shaping galaxies, even stopping new stars from forming. A cosmic regulator, a thermostat with no mercy. You drift upward again, above the whole cluster, and you see the same story playing out everywhere. There's no edge to this, no single moment where the universe decided, that's enough merging. From the earliest dwarf galaxies clumping together in the young universe, to the largest ellipticals absorbing their neighbours, to distant collisions still frozen in ancient light. It's all one long, elegant process. This is cosmic hierarchical growth. Galaxies merge. They form bigger galaxies. Those galaxies merge. Clusters form, then superclusters, and perhaps, someday, even those will collide. There's a famous case, the Bullet Cluster, where two galaxy clusters are in the middle of colliding, with their hot gas slowed by impact, but their dark matter passing through unaffected. It gave us one of the clearest pieces of evidence that dark matter is real, and separate from ordinary matter. You've seen that pattern tonight, again and again. Ordinary matter tangling, dark matter guiding, gravity always pulling. And here's your final quirky fact. Scientists predict that in the far future, perhaps 100 billion years from now, all the galaxies in our local group will have merged into one enormous elliptical galaxy. Everything else will have redshifted so far away, faster than the speed of light due to the expansion of the universe, that nothing outside will be visible. An island universe alone. No stars beyond it, no galaxies, no cosmic context. Future astronomers, if they exist, might think their galaxy is the entire universe. They won't be wrong from their point of view, but they'll never know what you know, that the universe was once alive with collisions. You drift now above it all, past galaxies mid-embrace, past tails of stars that stretch for light years, past clusters held together by invisible mass, past stars and dust and silence and light. You look back at the path you've followed, the first pull between two spirals, the slow warping, the violent flare of starbirth, the merging of black holes, the quiet settling, the final glow. And you see how it's never just one story, it's all stories, all galaxies, all times are always merging, always becoming. The universe doesn't end in a whisper, it doesn't end in fire either. It reshapes, it fades, it remembers. And you drift. One more speck of awareness, floating through the grandest collision of all. Let go now. Let the galaxies fade to blurs. Let the filaments dissolve. Let the stars shrink into silence. This part of the journey is complete. The universe continues. Let's slow everything down now. You've seen stars flung into the void, galaxies torn apart and remade, and black holes circling each other in dark gravitational dances older than memory. You've watched arms unfurl, warp, collapse, and settle again into something still, quiet, heavy with the echo of 1 billion years of motion. But now, everything is soft. You're drifting back from it all, from the last curled tidal tail, from the final elliptical shimmer glowing deep red with tired light. Behind you, the debris fades, the halos dim, and even the chaos of gravity feels gentler, like a breath exhaled. Out here, far from every core and filament, even the flicker of cosmic microwave background radiation feels warmer than the cold between galaxies. There's nothing urgent here, no light bright enough to wake you, no motion fast enough to disturb your drift. Just silence, wide, waiting, whole. You might still feel the memory of those first collisions, that slow draw between two spirals, the gas clouds folding into starbirth, the jets, the loops, the shells. But now they blur together, distant and soft, the way all big memories do when you're almost asleep. And that's all right. You've earned this calm. In a universe that moves with the rhythm of collisions, you've found a moment where nothing is coming closer. Nothing is being flung away. You're just here, suspended. Listening to the quiet curve of the cosmos, still ringing from a song it sang long before you arrived. Stay as long as you like. The galaxies will keep dancing without you. The black holes will keep circling, and the stars will keep burning in long, slow turns. But tonight there's nothing more to do. So close your eyes, whatever eyes you use out here, and rest. Everything is still moving, but you don't have to. Not now, not yet. Good night, sleepy traveller.